Okay, so let's give the scale function a try. So I'm going to download this scale function. And then in JES, I'll open it up. Go to the right folder, scale. So there's two scale recipes in here, one that scales up, and it does what I mentioned in the slides. It creates a source that's twice as big as the original, and then it uses this technique of incrementing by 0.5, but converting that value to an int when we get the color from the source. So that's how we're copying every pixel twice. And then we have the scale down, which creates a empty picture that is half as big as the original and increments the source X and source Y by 2, so that we're copying every other pixel in the original image. So let's just create a picture that we can scale. And notice this is returning a target value. Kind of like the butterfly for this one. So we'll use it's butterfly 2. And then picture equals make picture file. I'm going to show the picture. Okay, there's our butterfly. And now I want to scale it down. So I'm going to create a small butterfly by scaling down the picture of the original butterfly. Calling it butterfly might have been a better name. Oop, what did I do? Oh, I didn't load my program. Okay, load it, try again, scale it down. And that shouldn't take too long because we're copying every other picture. And so now I'll show the small butterfly. And there it is. I see that it's a quarter the size of the original because the width is half as much and the height is half as much. And now I'll go ahead and do the scale up. Picture. And that's taking longer because we're copying every pixel twice and we're creating an image that's 4 times as big as the original. So it's going to be a pretty large butterfly. So that's why this is running considerably more slowly than the scale down did. Should finish eventually. All right, and now we're going to show the big butterfly, and it should be 4 times as big, and it's huge. Okay. So that's the scale up and scale down, which are just either doubling or cutting the width and height in half. So what you want to do for your hands-on exercise is you're going to create a generic scale function. So I would take scale up and make a copy of it, copy the comments too, and change them so that they're correct. And what you're going to do is add a parameter to the scale. So change the name to scale, and you can do it in this same file if you want. Change the name to scale, and then add a parameter factor, and basically that factor is going to tell you how much you're going to scale by. So if it's 2, you would multiply by 2 here. If it's a half, you would multiply by 0.5 and so forth. So go ahead and multiply the width and height by the factor to get a picture that's the right size. You may have to use the int function there if you're passing in something like 0.5 or 0.3. So multiply by the factor to get the picture that's the right size. And then when it comes to incrementing here, instead of incrementing by 0.5, of course, what you want to do is you want to increment by 1.0 divided by the factor. And so what that does, like in this case, if our factor is 2, if I take 1.0, use a floating point value, so it doesn't do integer arithmetic. If I take 1.0 and divide by 2, I'm going to get 0.5. If I were to take 0.5 and divide 1.0 by 0.5, I would get 2, which is what I want when I'm scaling the picture down by half. So that's all you do is add factor here, and then multiply by factor instead of 2, and then divide 1 by the factor here to increment your source x and source y by the right amount. Be sure to use the int here when you get the pixel, and you may also need to use the int when you call the make empty picture because it expects integer arguments. And that's all there is to it. Good luck.